So we're going to look at a relationship between slopes of inverse functions. And we're not going to do inverse trig today. We'll do that in section 3-4. But just in general, inverse functions have kind of a cool relationship between their derivatives. Before we do that, though, let's take a look at inverses just to remind you about what we should know about inverses. First of all, we know that the domain and range are swapped. So the domain of f would be the range of the inverse and vice versa. We also know, and there's a picture of it right there, that the graph of the inverse is going to be a reflection of the function across the line y equals x. And the reason for that is that all of your ordered pairs on the inverse are swapped. So if a comma b is on f, then b comma a is on the inverse. For example, if I look at x equals 3, on f, maybe it's 2.5. So 3 comma 2.5 maybe is on f. And so that means that 2.5 comma 3 would be on the inverse. And then the other thing about functions and their inverses is that they undo each other. So if you compose f inverse with f of x, you get back to x. It's kind of how you undo f. And that should go in both directions. So that inverse slope relationship is the new calculus thing. And what we're saying is that the slopes of inverse functions at those corresponding points are reciprocals. So if I look at f, I can figure out the slope of f at this point. The slope of f at that point would be f prime of f inverse. So I can figure that out. And then f inverse, the slope of that would be the reciprocal. And they're going to be reciprocals at, not at the same x coordinate, but at those corresponding points, the slopes will be reciprocals. It kind of makes sense that the slopes are reciprocals because remember that the slope formula is going to be the y coordinates subtracted over the x coordinates subtracted. And if you have an inverse, all your x and y coordinates get flopped, so your slope would get flipped upside down. I also want to point out that these are not perpendicular slopes, so it's not opposite reciprocal, it's just reciprocal. Of course, I just claimed that, but I didn't prove anything. So let's go ahead and prove it. We're going to make use of these two ideas about inverse functions. Okay, so I'm going to start with f inverse of f of x equals x. And we know that's true because of the definition of inverse. Let's go ahead and take a derivative of both sides of that equation. So I'm going to take the derivative of f inverse, but this is kind of a chain rule here. It's exactly a chain rule. I'm taking the derivative of the mom, and then I'm going to leave the f of x alone inside because it's the baby. And then I'm going to take the derivative of f. And I'll take the derivative of the other side of the equation, and I get 1. So now I have the product of the slopes is 1, or if I solve for one of those slopes, like the f inverse prime of f of x, I get the reciprocal of f prime of x. And I want to point out that what this is saying is that f inverse prime of b is going to be the reciprocal, oops, I forgot the prime here, is going to be the reciprocal of f prime of A. So these two x coordinates are different because this is the y coordinate on F, which makes it the x coordinate on the inverse, and this is the x coordinate on F, which makes it the y coordinate on the inverse. All right, so this is that relationship in notation. We're saying that the slopes are reciprocals. So how might you use this fact? Well, one way you could use this fact is if you have a function, but you can't find its inverse. This is definitely a function that has an inverse. It's just that the inverse is hard to solve for. I can't get the equation for the inverse. But I'm interested in knowing the slope of the inverse at x equals -5. So remember, that means that since -5 is the x coordinate on the inverse, there must be some y coordinate, some x coordinate on F that gives me -5. So F of something would give me -5. If this is a non-calculated question, then we just are going to have to use guess and check. And if it's a calculator question, you could solve it for -5. But what I notice is that if I use a 0 for x, that works. So f of 0 gives me -5. So what we know from our reciprocal relationship is that f prime of -5 is going to be the reciprocal of, f inverse prime of -5 is going to be the reciprocal of f prime at 0, because those are the corresponding points. So that means this point right here, 0, -5 is on f. And on F inverse, the point that I'm interested in is at, and my scale is weird, is at -5, 0. Shouldn't have even put a picture there if I was going to give you a weird scale. Okay? Well, I can find f prime of 0. F prime of 0 is going to be, well, f prime is going to be 3x squared plus 3. So f prime of 0 would be 3. So that means that f inverse prime at -5 would be 1/3. Um, oh, I recommend you pause, try to figure out the second one, and then I'll talk through the second one and try to make sense this time. Right? So 9 is the y coordinate on F. It's the x coordinate on F inverse. So f of something equals 9. And it's not 0 this time. If you don't have a calculator, the numbers are going to be small and easy to check. So let's try f of 1. F of 1 would be 1 plus 3 minus 5. That's not it, because that would be -1. So let's try f of 2. F of 2 would be 8 plus 6 minus 5. Oh, that would be 9. Right. So I've found it. So that means that 2, 9 is on F. Now, what's the slope at 2? F prime would be, oh, we already did that. So F prime of 2 would be 3 times, we're looking at this equation, 3 times 4 plus 3, which would be 15. And so that means that the inverse function derivative at 9 would be the reciprocal of that, 1/15. Right? All these should be G's. All right. So this is the same type of problem. I would like to know what x-coordinate on G gives me a y-coordinate of -3, and I sure hope it's -1, and I'm looking at my picture and it looks like it's -1. So if I plug G of -1 would be -1 plus 3 minus 7 plus 2. Yeah, that's going to be -3. So that's good. I've got my ordered pair here. My ordered pair would be -1, -3. So I need to know the slope of G at -1. So G prime would be 7x to the 6th plus 6x plus 7. So G prime of -1 would be 7 minus 6 plus 7, or 8. This would be the reciprocal of that. I will leave that f inverse prime of 2 for you to solve on your own, but I will write the answer so that you can check it yourself later. All right. Here I'm just giving you some values in a table. So f and g are inverses, and we want to figure out what g prime of 0 is. Well, that means that the x-coordinate on G is 0, but that means the y-coordinate on F is 0. So that means on F, my x-coordinate is -1. So the slope at -1 would be -1/4, which means that I would use the reciprocal. So I would use -4. G prime of -3 means that the y-coordinate on G is -3. So the x-coordinate on F is 1, and the slope at that point is 11. So G prime of -3 would be 1/11. All right. Good luck. This is section 3-4. It's all about that inverse reciprocal relationship. Thank you.